Wars end, empires collapse, technologies evolve, and yet some machines simply refuse to disappear. Built in an era of world wars, nuclear standoffs, and industrial urgency, these military war machines were never expected to survive into the modern age. They were designed for short lifespans, brutal conditions, and immediate necessity. Instead, they endured. From bombers conceived in the early Cold War to weapons forged before television was common, these machines continue to fly, roll, sail, and fire decades after their creators are gone. Their survival is not an accident of history, but the result of design choices that favored reliability over elegance and function over perfection. In a world obsessed with replacement and innovation, these machines stand as living contradictions. Aging veterans still operating on today's battlefields, long after their time was supposed to end. B-52, Stratofortress, the 1950s, bomber still dominating the skies, the Boeing B-52. Stratofortress is one of the most extraordinary survivals in military aviation history. First, flown in 1952 and introduced into service in 1955, the B-52 was designed for a world shaped by early Cold War fears of nuclear conflict. More than 70 years later, it remains an active frontline weapon, continuing to deliver combat power in an era dominated by stealth aircraft, drones, and precision-guided munitions. The B-52 was originally built as a nuclear bomber intended to penetrate Soviet airspace and deliver atomic weapons deep behind enemy lines. To fulfill that mission, Boeing engineers prioritized range, payload capacity, and reliability. The aircraft's massive swept wings, 8 jet engines, and robust airframe allowed it to fly intercontinental missions with heavy payloads unmatched by any bomber of its era. From the beginning, the B-52 was less about speed and more about endurance and flexibility. What makes the B-52 remarkable is not merely its longevity, but its adaptability. While many Cold War aircraft were retired as technology advanced, the B-52 evolved continuously. It transitioned from a nuclear-only platform into a conventional bomber, capable of carrying cruise missiles, smart bombs, and standoff weapons. During the Vietnam War, it became synonymous with large-scale bombing campaigns. In later conflicts, it proved equally effective delivering precision strikes from high altitude. Structurally, the aircraft was overbuilt by modern standards, and that proved to be its greatest strength. The B-52's airframe can withstand decades of stress and repeated upgrades. Unlike stealth bombers designed around tightly integrated systems, the Stratofortress offers ample internal space for new electronics, sensors, and weapons. This allowed the U.S. Air Force to modernize the aircraft repeatedly rather than replace it. Economic reality also favored the B-52. Developing an entirely new bomber fleet is staggeringly expensive, while upgrading an existing platform costs far less. Over time, the B-52 became one of the most cost-effective strategic assets in the U.S. arsenal. Its maintenance requirements are well understood, spare parts are plentiful, and crews are extensively trained. Even its subsonic speed is less of a disadvantage in an age of long-range missiles. The aircraft's operational relevance has extended into the 21st century. B-52s have flown combat missions in Iraq, Afghanistan, Syria, and beyond, often launching weapons from outside hostile airspace. They also play a critical deterrence role, conducting visible patrols near potential adversaries to signal strategic resolve. Few aircraft can match that combination of symbolism and capability. Ironically, the B-52 has outlived aircraft that were once intended to replace it. Newer bombers came and went, while the Stratofortress remained indispensable. The U.S. Air Force now plans to keep upgraded B-52s in service into the 2050s, meaning some airframes may approach a full century of operation. The B-52 endures because it was designed around fundamentals that never became obsolete: range, payload, reliability, and adaptability. In a constantly changing battlefield, the Stratofortress proves that the right design can transcend generations, making a 1950s bomber one of the most relevant war machines still flying today. T-34, tank, the World War II icon that refuses to die. The Soviet T-34 is one of the most influential and enduring military vehicles ever built. Introduced in 1940 on the eve of World War II, it was designed for a conflict defined by mass production, harsh terrain, and relentless attrition. More than 8 decades later, the T-34 remains operational in limited roles, training units, museums, and even ceremonial service, making it one of the oldest military machines still capable of movement and function. The T-34 was revolutionary, not because it excelled in one area, but because it balanced several critical elements better than any tank of its time. It combined sloped armor, wide tracks, and a powerful diesel engine into a design that was simple, rugged, and highly adaptable. Sloped armor increased effective thickness without adding weight, allowing the tank to deflect enemy rounds while remaining relatively mobile. Western tank designers would later adopt this principle universally. Mobility was central to the T-34's success. Its wide tracks distributed weight evenly, allowing it to operate in mud, snow, and soft ground, where narrower tracked tanks became immobilized. This proved decisive on the Eastern Front, where weather and terrain destroyed as many vehicles as enemy fire. The T-34 could keep moving when others could not, a trait that defined its battlefield reputation. Equally important was its diesel engine. At a time when many tanks relied on gasoline, the T-34's diesel power plant reduced fire risk and performed more reliably in extreme cold. The engine was mechanically simple, tolerant of abuse, and easy to repair under field conditions. Crews with minimal training could keep the tank running, a critical advantage for the Soviet Union during periods of catastrophic losses. Production philosophy ensured the T-34's survival long after the war. It was designed for mass manufacturing, not precision craftsmanship. Factories could produce it quickly, often under bombardment, using semi-skilled labor. Over 80,000 units were built, making spare parts abundant and repairs feasible decades later. This overproduction unintentionally guaranteed its longevity. After World War II, thousands of T-34s remained in service worldwide. Many countries adopted them as frontline tanks, while others repurposed them for training, engineering, or static defense roles. Some were converted into recovery vehicles or tractors, stripping away armament but retaining mobility. In several nations, T-34s remained in official military inventories into the late 20th century. What makes the T-34 remarkable today is not combat relevance, but durability. Unlike modern tanks filled with sensitive electronics, the T-34 relies on mechanical systems that can be maintained indefinitely with basic tools. Its steel structure, forgiving tolerances, and straightforward layout allow continued operation long after newer vehicles become unserviceable. The T-34 also survives as a symbol. It appears in military parades, museums, and memorials, often running under its own power. In some regions, restored examples are still driven regularly, not as weapons but as functioning machines from a different era. The T-34 refuses to die because it was built for reality, not perfection. It was engineered to survive poor maintenance, brutal weather, and constant use. That philosophy carried it through war, peace, and generations of technological change. As a result, the T-34 stands as one of the last truly immortal war machines of the 20th century. C-130, Hercules, the workhorse, transport flying for over 70 years. The Lockheed C-130, Hercules is one of the longest-serving and most versatile military aircraft ever built. First flown in 1954, the C-130 was designed to meet a straightforward requirement: transport troops, vehicles, and supplies into rough, forward areas with minimal infrastructure. More than 70 years later, it continues to fly active missions worldwide, proving that adaptability and reliability can outlast generations of newer designs. From the outset, the C-130 was engineered for practicality rather than prestige. Its high-mounted wings, rugged landing gear, and powerful turboprop engines allowed it to operate from short, unpaved runways where jet aircraft could not safely land. This capability made it indispensable in conflicts and humanitarian operations alike. Unlike larger strategic airlifters, the Hercules could deliver cargo directly to frontline units instead of relying on established airfields. What truly sets the C-130 apart is its structural durability. The airframe was designed to absorb repeated stress from short takeoffs, heavy loads, and uneven landing surfaces. This overbuilt construction allowed aircraft produced in the 1950s and 1960s to remain viable decades later. While many aircraft of similar age were retired due to metal fatigue or maintenance complexity, the C-130 continued flying with manageable upgrades and inspections. The aircraft's adaptability is unmatched. Over time, the C-130 platform evolved into dozens of variants serving vastly different missions. It has been used as a cargo hauler, troop transport, aerial tanker, gunship, search and rescue aircraft, weather reconnaissance platform, and electronic warfare system. The AC-130 gunship, in particular, transformed the transport into one of the most feared close air support platforms ever fielded, demonstrating how flexible the basic design truly was. Economic factors also contributed to the C-130's longevity. Developing a new military aircraft is enormously expensive, while upgrading an existing proven platform is far more cost-effective. The Hercules offered ample internal space and power margins to accept modern avionics, sensors, and defensive systems without redesigning the aircraft from scratch. This allowed air forces to modernize capabilities incrementally rather than commit to risky replacement programs. The C-130's turboprop engines, often seen as outdated, became another advantage. They provide excellent fuel efficiency at low and medium altitudes, superior loiter time, and strong performance in hot and high conditions. In many missions, jet speed offers little benefit, while endurance and reliability matter far more. The Hercules was optimized for the missions militaries actually needed to fly. Operational history reinforced its value. The C-130 has served in virtually every major conflict since the Vietnam War, as well as countless disaster relief operations. It has delivered aid after earthquakes, hurricanes, and floods, often becoming the first large aircraft to land in devastated regions. This dual military and humanitarian role ensured continued political and financial support. Today, new variants like the C-130J Super Hercules continue production, while older models remain operational after extensive refurbishment. Few aircraft can claim such uninterrupted relevance. The C-130 Hercules endures because it was built around a timeless principle. A machine that can do many jobs reliably will never truly become obsolete. MiG-21, the Cold War fighter still in active service. The McCoy and Gurevich MiG-21 is one of the most enduring combat aircraft in aviation history. First flown in 1955 and introduced into service in 1959, the MiG-21 was designed at the height of the Cold War as a fast, simple, and affordable interceptor. More than 60 years later, variants of the aircraft are still flying in active military service, an achievement unmatched by most supersonic fighters. The MiG-21 was built around a clear and pragmatic philosophy. Soviet designers prioritized speed, climb rate, and ease of production over comfort and sophistication. The aircraft's lightweight delta wing design allowed it to exceed Mach 2, making it one of the fastest fighters of its era. At the same time, its small size reduced radar visibility and made it difficult to hit in combat. These characteristics made the MiG-21 highly effective as a point defense interceptor against bombers and reconnaissance aircraft. What truly enabled the MiG-21's longevity was its simplicity. The aircraft used straightforward mechanical systems, minimal avionics, and an engine optimized for reliability rather than long service intervals. Early variants lacked advanced radar or complex electronics, which limited capability but dramatically improved maintainability. In austere environments, ground crews could keep MiG-21s operational with basic tools and limited infrastructure, a decisive advantage for air forces with constrained resources. production scale played a critical role in the aircraft's survival. More than 11,000 MiG-21s were built across the Soviet Union, and licensed manufacturers in Eastern Europe, Asia, and beyond. This massive output ensured abundant spare parts, technical knowledge, and trained personnel worldwide. Even decades after production slowed, countries could maintain fleets without depending on fragile supply chains. Combat experience reinforced the aircraft's relevance. The MiG-21 saw action in Vietnam, the Middle East, South Asia, Africa, and Eastern Europe. While it faced limitations against newer Western fighters, skilled pilots consistently demonstrated that the MiG-21 remained dangerous when used correctly. Its speed, acceleration, and small profile allowed it to exploit mistakes by more complex adversaries. Modernization extended the aircraft's life well beyond original expectations. Many nations upgraded their MiG-21 fleets with improved radar, avionics, electronic warfare systems, and modern missiles. These upgrades transformed a 1950s design into a credible light fighter well into the 21st century. While no longer competitive against top-tier modern jets, upgraded MiG-21s remain effective for air policing, training, and secondary combat roles. Economic reality is the final reason the MiG-21 refuses to disappear. Replacing a fighter fleet is enormously expensive, and not every country requires cutting-edge stealth or networked warfare capabilities. For many air forces, the MiG-21 offers an affordable way to maintain supersonic interception and pilot proficiency without unsustainable costs. Today, the MiG-21 continues flying in a shrinking but notable number of air forces. Its survival is not accidental. It reflects a design optimized for mass use, harsh conditions, and long-term practicality rather than technological perfection. The MiG-21 endures because it was built for a world where simplicity, speed, and reliability mattered more than sophistication. In doing so, it became one of the last truly immortal fighters of the Cold War era. A K-47, the rifle that outlived the century. Few weapons in history have achieved the longevity, global reach, and cultural impact of the AK-47. Designed in the final years of World War II and officially adopted by the Soviet Union in 1949, the Avtomat Kalashnikova was created to meet a specific military need. Instead, it became the most widely used firearm on Earth, remaining in active service more than 75 years after its introduction. The AK-47 was born from hard wartime lessons. Soviet forces needed a rifle that combined the firepower of a submachine gun with the range of a traditional infantry weapon. It had to function in mud, snow, sand, and extreme cold, while being simple enough for mass conscription armies. Mikhail Kalashnikov's design answered those demands with brutal efficiency. What made the AK-47 revolutionary was not accuracy or refinement, but reliability. The rifle used loose mechanical tolerances that allowed dirt, debris, and ice to pass through the action without causing jams. Its long-stroke gas piston system delivered consistent operation even under severe neglect. While Western rifles emphasized precision machining, the AK emphasized function under abuse. This design choice defined its survival. Ease of manufacture ensured its spread. The AK-47 could be produced using relatively simple industrial equipment, stamped components, and minimal finishing. During the Cold War, the Soviet Union licensed production to Allied states across Eastern Europe, Asia, and Africa. Millions were produced legally, and countless more through unauthorized copies. The rifle became a standard tool of armies, insurgents, militias, and revolutionary movements worldwide. Combat history reinforced its reputation. The AK-47 and its variants were used in nearly every major conflict since the 1950s, from Vietnam and the Middle East to Africa and Eastern Europe. While not the most accurate rifle, it proved lethal in real-world conditions where dust, humidity, and poor maintenance crippled more delicate weapons. Soldiers learned that an AK would fire when others failed, and the trust mattered more than theoretical performance. Longevity was further ensured by adaptability. Over time, the AK platform evolved into countless variants, including the AKM, AK-74, and modernized versions with improved ergonomics, optics mounts, and ammunition. Despite technological updates, the core operating system remained unchanged. This continuity allowed decades-old rifles to remain serviceable alongside modernized counterparts. Economic factors cemented its survival. For many nations, replacing an entire infantry arsenal is prohibitively expensive. The AK-47 offers a low-cost, low-maintenance solution that requires minimal training. Ammunition is abundant, spare parts are interchangeable, and skilled armorers are found worldwide. Few weapons offer such logistical simplicity. Even today, the AK-47 remains in active military and paramilitary service across multiple continents. It appears in regular armies, reserve forces, and internal security units. Its silhouette has become a political symbol, appearing on flags, emblems, and propaganda, an indication of how deeply it has embedded itself into global history. The AK-47 outlived the Cold War, the Soviet Union, and generations of supposedly superior replacements. It endures because it was designed for reality rather than ideal conditions. In doing so, it became not just a rifle, but one of the most enduring machines of the modern age. M113, Armored Personnel Carrier, the Vietnam era, vehicle still rolling. The M113 Armored Personnel Carrier is one of the most enduring ground combat vehicles ever produced. First entering service with the U.S. Army in 1960, the M113 was designed to transport infantry safely across a modern battlefield, shaped by machine guns, artillery, and nuclear-era doctrine. More than 6 decades later, it remains in active service across the world, a testament to durability, adaptability, and pragmatic engineering. The original concept behind the M113 was simplicity. Military planners needed a lightweight air-transportable vehicle that could move troops quickly while offering protection from small arms fire and shell fragments. The result was a boxy, aluminum-hulled vehicle that prioritized mobility and ease of production over heavy armor. At the time, this was a radical choice. Aluminum reduced weight significantly, allowing the M113 to be faster, easier to transport, and capable of swimming across rivers without preparation. The Vietnam War cemented the M113's reputation. Deployed extensively by U.S. and Allied forces, it proved capable of operating in jungles, mud, rice paddies, and extreme heat. While not immune to heavy weapons, it offered far greater protection than trucks or jeeps and allowed infantry to maneuver under fire. Soldiers quickly adapted it beyond its original role, mounting machine guns and using it aggressively in combat rather than purely as a transport. What truly allowed the M113 to survive into the modern era was its mechanical simplicity. The vehicle used straightforward automotive components, a reliable engine, and uncomplicated suspension. Maintenance could be performed in the field with basic tools, a critical advantage for prolonged operations. Unlike more complex armored vehicles, the M113 tolerated abuse, poor maintenance, and harsh environments without catastrophic failure. Production scale ensured its longevity. Over 80,000 M113s were built, making it one of the most widely produced armored vehicles in history. This massive output created a global ecosystem of spare parts, trained mechanics, and upgrade programs. Even decades after initial production, keeping an M113 operational remained economically viable for many countries. Adaptability became the vehicle's defining trait. The M113 chassis was modified into dozens of variants, including command vehicles, ambulances, mortar carriers, air defense platforms, and engineering vehicles. Many nations upgraded their fleets with improved engines, additional armor, and modern electronics. While these versions differ significantly from the original, they retain the same basic structure introduced in the 1960s. Modern combat did expose the M113's limitations. Against advanced anti-tank weapons and improvised explosive devices, its protection is insufficient. As a result, many frontline armies replaced it with heavier infantry fighting vehicles. Yet replacement did not mean retirement. the M113 shifted into secondary roles where its strengths still mattered: logistics, medical evacuation, internal security, and support missions. Today, the M113 remains in service with dozens of military forces worldwide. Some units are more than half a century old, yet continue operating reliably after repeated refurbishments. Few military vehicles can claim such sustained relevance across radically different eras of warfare. The M113 survives not because it is perfect, but because it is practical. It was engineered to be affordable, adaptable, and easy to keep running. In a world where military technology often becomes obsolete within decades, the M113 stands as proof that simple, well-balanced design can roll far beyond its original battlefield. Tu-95 Bear, the propeller bomber that never left the front line. The Tupolev Tu-95, known to NATO as the Bear, is one of the most unusual and enduring military aircraft ever built. First flown in 1952 and entering service in 1956, the Tu-95 was designed as a strategic nuclear bomber for the Soviet Union at the height of the Cold War. Remarkably, it remains in active service today, making it one of the oldest frontline combat aircraft still flying anywhere in the world. What immediately sets the Tu-95 apart is its propulsion. Unlike modern strategic bombers powered by jet engines, the Tu-95 uses four massive turboprop engines driving contra-rotating propellers. This configuration looks outdated, yet it was a deliberate and highly effective engineering choice. Turboprops provided far greater fuel efficiency at long ranges than early jet engines, allowing the Tu-95 to patrol enormous distances without refueling. Range, not speed, was the aircraft's primary mission requirement. The Tu-95 was built to carry nuclear weapons deep into enemy territory. Its large airframe, swept wings, and powerful engines gave it intercontinental reach, enabling missions from Soviet bases to targets across the Atlantic or Pacific. While it was slower than jet-powered bombers, it could remain airborne for extremely long durations, making it ideal for deterrence patrols and strategic signaling. Durability has been central to the Bear's survival. The aircraft was overbuilt by modern standards, with robust structural components designed to handle long flights, heavy payloads, and repeated upgrades. Its systems are largely mechanical and accessible, allowing maintenance crews to keep airframes operational decades beyond their original service expectations. This ruggedness has allowed the Tu-95 to endure where more delicate designs have failed. Adaptation is another reason the aircraft never left the front line. While its original mission centered on free-fall nuclear bombs, the Tu-95 evolved into a missile carrier. Modern variants can launch long-range cruise missiles from well outside hostile airspace, eliminating the need to penetrate advanced air defenses. This transformation preserved the aircraft's relevance in an era of surface-to-air missiles and stealth fighters. The Bear also plays a crucial psychological and strategic role. Tu-95s regularly conduct long-range patrols near NATO airspace, often intercepted by Western fighters. These missions are not accidental. They are deliberate demonstrations of reach, readiness, and deterrence. The unmistakable sound of the Tu-95's propellers, audible even inside nearby aircraft, has become a symbol of Cold War continuity in modern skies. Economic reality reinforces its continued use. Developing a new strategic bomber is enormously expensive and time-consuming. By contrast, upgrading an existing platform with new avionics, sensors, and weapons is far more cost-effective. The Tu-95's large internal volume and strong power margins make modernization practical, allowing Russia to extend its service life at a fraction of replacement cost. Operational history confirms its value. The Tu-95 has served continuously from the Cold War through the post-Soviet era, participating in patrols, exercises, and modern conflicts. Few military aircraft can claim such uninterrupted frontline relevance across radically different geopolitical landscapes. The Tu-95 Bear endures because it was designed around fundamentals that never lost importance: range, reliability, and adaptability. Its propellers may belong to an earlier era, but its mission does not. More than 70 years after its first flight, the Bear remains a frontline strategic weapon, proving that effective design can transcend generations of technological change. Leopard 1 tank, the Cold War armor still deployed worldwide. The Leopard 1 tank stands as a striking example of Cold War military design that continues to operate long after its expected retirement. Introduced in the mid-1960s by West Germany, the Leopard 1 was developed under a radically different philosophy from many of its contemporaries. Instead of prioritizing heavy armor, its designers emphasized mobility, firepower, and reliability, choices that ultimately allowed the tank to remain relevant for decades. The Leopard 1 emerged from the strategic realities of post-war Europe. NATO planners understood that Soviet numerical superiority in tanks made sheer armor thickness impractical. German engineers concluded that no realistic amount of armor could guarantee survival against modern anti-tank weapons. As a result, the Leopard 1 was designed to avoid enemy fire through speed and maneuver rather than absorb it. This concept marked a sharp departure from World War II thinking and defined the tank's long-term utility. At the heart of the Leopard 1 was its exceptional mobility. Powered by a reliable multi-fuel diesel engine, the tank could reach high road speeds and maintain excellent cross-country performance. Its advanced suspension allowed smooth movement over rough terrain, improving accuracy while on the move. This mobility made the Leopard 1 ideal for rapid redeployment, reconnaissance, and defensive maneuvers across Europe's varied landscapes. Firepower ensured the tank remained credible despite lighter armor. The Leopard 1 was armed with the British-designed 105mm L7 rifled gun, one of the most successful tank cannons ever produced. This weapon provided excellent accuracy, penetration, and compatibility with a wide range of ammunition. Even as armor technology evolved, the L7 allowed the Leopard 1 to engage enemy vehicles effectively well into the late Cold War. Simplicity and reliability played a major role in the tank's longevity. The Leopard 1 used conventional mechanical systems that were easy to maintain and repair. Crews could service the tank with relative ease, and spare parts were widely available due to extensive production runs. Over 4,700 units were built, many exported to allied nations across Europe, South America, Africa, and Australia. This global distribution created long-term logistical support networks that kept the tank viable. Modernization programs further extended its service life. Many operators upgraded their Leopard 1 fleets with improved fire control systems, thermal sights, laser rangefinders, and enhanced communications. Some variants received additional armor or were converted into specialized vehicles such as bridge layers, recovery vehicles, and engineering platforms. These upgrades allowed older hulls to remain operational without the expense of acquiring entirely new tanks. While no longer suited for high-intensity frontline combat against modern main battle tanks, the Leopard 1 continues to serve in secondary and support roles. It is used for training, reconnaissance, fire support, and territorial defense by multiple countries. In recent conflicts, refurbished Leopard 1 variants have even returned to combat zones, proving that the platform still holds tactical value under the right conditions. The Leopard 1 endures because it was built around realistic assumptions rather than extremes. By prioritizing mobility, firepower, and maintainability over excessive armor, its designers created a tank capable of adaptation. Decades after the Cold War that shaped it, the Leopard 1 remains deployed worldwide, a reminder that balanced design often outlasts brute force in military engineering. Mi-8 Helicopter, the military transport that will not retire. The Mi-8 helicopter is one of the most successful and enduring military aircraft ever built. First flown in 1961 and entering service shortly afterward, the Mi-8 was designed as a simple, rugged transport helicopter for the Soviet armed forces. More than 6 decades later, it remains in active military service across the world, defying generations of newer and more technologically advanced replacements. From the beginning, the Mi-8 was engineered for reliability rather than refinement. Soviet planners needed a helicopter capable of operating across vast territories with limited infrastructure, extreme climates, and minimal maintenance support. The result was a large, twin-engine helicopter with a spacious cabin, powerful lifting capability, and systems designed to function under neglect and abuse. This philosophy ensured the Mi-8 could operate where failure was not an option. One of the helicopter's greatest strengths is its versatility. The Mi-8 can transport troops, cargo, weapons, fuel, and medical teams with minimal modification. It can be configured as a troop carrier, gunship, airborne command post, electronic warfare platform, or medical evacuation helicopter. This adaptability allowed militaries to rely on a single airframe for dozens of mission profiles, reducing training and logistical complexity. Cold weather performance further cemented the Mi-8's reputation. The helicopter was built to operate in Arctic, desert, jungle, and mountainous environments. Its engines and systems were designed to start and function in extreme temperatures, including deep sub-zero conditions common in Siberia and Central Asia. While many Western helicopters required hangars and climate-controlled maintenance, the Mi-8 could be left outdoors and flown reliably. Mechanical simplicity is central to its longevity. The Mi-8 uses robust, accessible systems with minimal reliance on sensitive electronics. Maintenance crews can perform field repairs using basic tools, even far from major air bases. This makes the helicopter particularly valuable for militaries with limited budgets or operating in remote regions. Failures are often gradual rather than catastrophic, allowing crews to manage problems without grounding the aircraft. Production scale ensured global survival. Over 17,000 Mi-8s and its improved variants have been built, making it the most produced helicopter in history. Licensed production and exports spread the aircraft across Eastern Europe, Asia, Africa, and the Middle East. This created a vast global supply of spare parts, experienced pilots, and maintenance knowledge that continues to support operations decades after initial production. Combat history reinforced its relevance. The Mi-8 has seen action in nearly every major conflict involving Soviet or Russian forces since the 1960s, as well as numerous regional wars worldwide. It has transported troops into combat zones, evacuated wounded soldiers under fire, and delivered supplies to isolated units. Even when armed with machine guns, rockets, or missiles, it remained primarily a transport, one that could defend itself if necessary. Modernization has kept the Mi-8 viable into the 21st century. Updated variants feature improved engines, modern avionics, night vision compatibility, and enhanced survivability systems. While newer helicopters offer advanced sensors and stealth features, they often come at far greater cost and maintenance burden. Today, the Mi-8 remains active in military service across dozens of countries. It continues flying missions that demand reliability, capacity, and adaptability rather than cutting-edge technology. The Mi-8 will not retire because it fulfills a role that never disappeared. It was built for reality, not perfection, and that decision allowed it to outlast generations of modern war machines. LST Landing Ships, World War II, vessels still crossing oceans. Landing Ship Tank, LST. Vessels were among the most consequential yet underappreciated war machines of World War II. Designed in urgency and built in enormous numbers, these blunt, boxy ships were never meant to be elegant. They were meant to work. More than 8 decades later, that brutal practicality explains why some LSTs, or direct descendants of their design, are still crossing oceans and operating worldwide. The LST concept emerged from a critical Allied problem early in World War II: how to land tanks, trucks, and troops directly onto hostile beaches without relying on captured ports. The solution was radical. Engineers designed a large, ocean-going ship with a shallow draft, flat bottom, and massive bow doors that could open onto a ramp. An LST could sail across the Atlantic, then drive armored vehicles straight onto a beach under fire. First entering service in 1942, LSTs quickly became indispensable. They played decisive roles in major amphibious operations, including Sicily, Normandy, and the Pacific Island campaigns. Each vessel could carry dozens of tanks, trucks, or hundreds of troops, along with fuel and supplies. They were slow and ungainly, but their ability to deliver heavy equipment directly ashore changed how wars were fought. What made LSTs truly enduring was their construction philosophy. They were built to merchant ship standards rather than fragile warship tolerances. Hulls were thick, systems were simple, and engines were chosen for reliability over speed. Damage resistance mattered more than refinement. Many LSTs survived direct hits, beachings, and severe storms, often returning to service with minimal repair. After World War II, thousands of LSTs remained in service rather than being scrapped. Navies quickly realized their peacetime value. LSTs became transport ships, disaster relief platforms, hospital ships, and logistics vessels. Their large cargo decks and ability to operate without port infrastructure made them ideal for humanitarian missions, especially in developing regions and island nations. Cold War conflicts extended their relevance. LSTs were used extensively during the Korean War and later conflicts, transporting vehicles and supplies where ports were damaged or non-existent. Many were transferred to Allied nations, where they remained active for decades. Some hulls built in the 1940s were still operating into the 1990s and beyond. Even where original World War II LSTs are no longer active, their design lives on. Modern landing ships and roll-on roll-off military transports directly trace their lineage to the original LST concept. The bow ramp, shallow draft, and beaching capability remain essential for amphibious and logistics operations. In civilian roles, former LSTs and LST-derived ships still transport cargo, vehicles, and construction equipment across oceans and rivers. Their longevity also reflects economics. LSTs are cheap to operate compared to modern warships. They require smaller crews, simpler maintenance, and minimal port infrastructure. For many nations, especially those with limited naval budgets, an aging but functional LST is far more valuable than an advanced ship they cannot afford to maintain. Today, surviving LSTs are often quietly at work rather than celebrated. They deliver aid after earthquakes, resupply remote islands, and move heavy equipment where modern ports do not exist. Their continued service is not nostalgia, it is necessity. The LST proves a rare truth in military engineering. When a machine is built for fundamental needs, cargo, access, reliability, it can outlive not just wars, but entire technological eras. DShK heavy machine gun, the 1930s weapon still firing today. The DShK heavy machine gun is one of the most enduring weapons ever produced, a design born in the 1930s that continues to see active use nearly a century later. Few military systems demonstrate longevity so clearly. While aircraft, tanks, and vehicles are routinely replaced or modernized, the DShK remains fundamentally unchanged, still performing the same battlefield roles it was designed for before World War II. The weapon was developed by Soviet engineers Vasily Degtyaryov and Georgy Shpagin, entering service in 1938. Its purpose was straightforward but critical: provide infantry units with a heavy-caliber weapon capable of engaging aircraft, vehicles, and fortified positions. Chambered in the powerful 12.7 by 108 mm cartridge, the DShK delivered destructive force far beyond that of standard infantry weapons. This made it suitable as both an anti-aircraft gun and a ground support weapon. From the beginning, the DShK was engineered for durability rather than refinement. Its design emphasized thick steel components, generous tolerances, and mechanical simplicity. These choices allowed the weapon to function reliably in extreme heat, freezing cold, sand, dust, and mud. Where more delicate systems failed, the DShK kept firing. This reliability became its defining trait. During World War II, the DShK was mounted on tripods, vehicles, ships, and armored platforms. It defended Soviet columns against low-flying aircraft, destroyed lightly armored vehicles, and suppressed enemy positions. Although heavy and cumbersome compared to lighter machine guns, its power justified the burden. Soldiers trusted it because it rarely malfunctioned when properly maintained. After the war, the DShK's usefulness expanded rather than diminished. The Cold War spread Soviet weapons across the globe, and the DShK was exported or licensed in dozens of countries. It appeared in Asia, the Middle East, Africa, and Latin America, becoming a staple of both regular armies and irregular forces. Its ability to be mounted on trucks, armored vehicles, or improvised platforms made it exceptionally versatile. One reason the DShK remains relevant is its adaptability. The gun can be used against infantry, vehicles, helicopters, drones, and low-flying aircraft. In modern conflicts, it is frequently mounted on pickup trucks, providing mobile firepower with minimal logistical support. Against lightly armored targets and aerial threats, it remains highly effective despite its age. Logistics also play a major role in its survival. The 12.7 x 10 to the 8th mm ammunition is widely produced and stockpiled, especially in countries that once aligned with the Soviet Union. Spare parts are simple to manufacture, and many components can be repaired rather than replaced. Unlike modern weapons that rely on electronics or advanced materials, the DShK can be kept operational with basic tools and machining. Western analysts have often noted that the DShK's continued use reflects a different philosophy of warfare. It prioritizes reliability, intimidation, and sustained fire over precision or technological sophistication. In many environments, particularly in developing regions or prolonged conflicts, those qualities matter more than cutting-edge capability. Today, the DShK remains in service with military units, paramilitary forces, and border guards around the world. It guards convoys, protects installations, and provides fire support in conflicts that look very different from those of the 1930s. Yet, the weapon itself has not needed reinvention. The DShK endures because it was built around a simple truth. A weapon that always works is more valuable than one that is advanced but fragile. Nearly a century after its introduction, it continues to fire, not because it is outdated, but because it is still exactly what many battlefields demand. Ural 4-320. Military truck, the Soviet transport built to last forever. The Ural 4-320 is one of the most durable military vehicles ever produced, a truck so robust that it has outlived the Soviet Union itself. Introduced in 1977, the Ural 4-320 was designed to operate in the most hostile environments imaginable, from Siberian winters to desert heat, with minimal maintenance and maximum reliability. More than 4 decades later, it remains in active service across military and civilian sectors, proving that longevity can be engineered deliberately. The truck was developed as a successor to earlier Ural models, incorporating lessons learned from decades of Soviet military logistics. Engineers focused on one overriding principle: the vehicle must keep moving no matter the conditions. To achieve this, the Ural 4-320 was built around a heavy-duty ladder frame, a permanent 6x6 drivetrain, and massive off-road tires designed to grip snow, mud, sand, and rock. Roads were considered optional rather than essential. Cold weather performance was a core requirement. Soviet planners expected the truck to function reliably at temperatures below -40°C. The diesel engine was deliberately understressed, producing high torque at low RPM rather than high speed. This allowed the truck to haul heavy loads through resistance-heavy terrain without overstressing components. Preheating systems, simple fuel delivery, and wide mechanical tolerances ensured the engine could start after long exposure to extreme cold. Unlike modern military trucks, the Ural 4-320 relies almost entirely on mechanical systems. Electronics are minimal or non-existent in early variants. This design choice dramatically increased reliability in environments where moisture, freezing temperatures, or electromagnetic interference could disable more advanced vehicles. Field repairs could be performed with basic tools, and crews were trained to keep the truck operational far from supply depots or workshops. Versatility further cemented the truck's reputation. The Ural 4320 served as a troop carrier, cargo hauler, fuel tanker, mobile workshop, and artillery tractor. It also became a common platform for rocket launchers, radar systems, communications equipment, and air defense weapons. This adaptability simplified logistics, allowing the same vehicle type to support multiple roles across vast distances. Western engineers often criticized the Ural 4320 for being heavy, loud, and inefficient. Fuel consumption was high, and driver comfort was minimal. These traits were not oversights, they were accepted trade-offs. The truck was expected to be overloaded, poorly maintained, and continuously operated under combat conditions. It was built to degrade slowly rather than fail suddenly, a critical distinction in remote or hostile regions. The collapse of the Soviet Union did not end the Ural 4320's service. Thousands of trucks transitioned into civilian roles, supporting oil fields, mining operations, forestry, and disaster response in remote regions. In many areas, replacing them made little economic sense. Newer vehicles were more efficient but less tolerant of neglect and harsh conditions. Modernized versions of the Ural 4320 are still being produced, incorporating updated engines and safety features while preserving the original design philosophy. This continuity is rare in military vehicle development and reflects the truck's fundamental soundness. The Ural 4320 was never meant to be impressive. It was meant to survive. In doing so, it became one of the longest-serving military transport vehicles in history. Its continued presence on roads, trails, and frozen landscapes is proof that when durability is prioritized above all else, a machine can approach something close to immortality.